Thank you for watching my presentation. My name is Dohyeon Lee. I'm going to talk about accumulation of ideas and the declining entry rate. New firms entry is an important source of economic growth and job creation. There has been decline in the entry rate of new firms in the US as well as in other advanced economies. Existing studies have focused on the entrant size to explain the declining entry rate. In contrast, in this paper, I show how improvement in the incumbent's performance can lead to the declining entry rate. Over time, the economy becomes populated with more of the better firms. At the intensive margin, existing firms can improve by, for example, R&D or learning by doing. Even if this intensive margin were absent, at the extensive margin, between any 2 points in time, there are new firms that enter. And due to selection, only the high productivity firms would enter and survive, while the low productivity firms would have to exit. As a result, the pool of incumbent firms becomes stronger over time. Now, facing a stronger pool of incumbents, entry becomes less profitable, so there is less entry. Most importantly, my model achieves a fair comparison between incumbents and entrants, whereas the existing studies cannot do a fair comparison. And what do I mean by fair comparison? In a nutshell, if the stronger pool of incumbents forces the low productivity incumbents to exit, it should also discourage low-quality entrants from entering the market. Surprisingly, existing studies fail to capture this story. So my explanation is qualitatively different from existing studies. Here is some motivating evidence. The solid black line is the entry rate in the US, and the red dashed line is the employment share of new firms. The entry rate is defined as the number of new firms divided by the number of existing firms in the previous period. We can see clear downward trends in both of these series over the past 4 decades. Here's the summary of what I do. First, I build a model that explains the decline of entry rate. Again, this achieves a fair comparison between incumbents and entrants. And I show how existing models with stationary age distribution cannot do a fair comparison. Second, I propose and estimate an alternative measure of entry that is also informative about the degree of the incumbent firm's advantage. Lastly, in the quantitative section, there are 2 main exercises. First, I do a decomposition of the aggregate productivity growth into the intensive and extensive margins. Second, as a counterfactual analysis, I consider hypothetical path of population growth, which connects to one of the leading explanations for the declining entry rate. Now let me proceed to the model, which is a model of ideas and entrepreneurial choice. Here's the model environment. The population is endogenously divided into workers and entrepreneurs. Running a business as an entrepreneur requires an idea or a blueprint. And the quality of an idea serves as the productivity for producing that good. In the beginning of each period, some workers find new ideas. There's an exogenous arrival of ideas which are drawn from some given distribution. Once found, an idea remains permanently at the initial quality, which is natural if we think of the actual blueprint. After the ideas are found, occupation choices are made. Entry is the transition from worker to entrepreneur, and this occurs if the new idea is better than the current threshold. Exit is the transition in the opposite way, and this occurs if the previously owned idea becomes inferior to the current threshold. Note that the exit occurs not because one's own productivity decreases, but because the threshold idea rises over time. Because there is no cost of entry or exit, the threshold for both entry and exit coincide. And at this common threshold, profit is equal to the wage, which is the choice of numeraire. Just to fix ideas, we can make the following assumptions. The production is constant returns to scale using labor inputs only, taking one's blueprint as given. And the standard monopolistic competition we see as demand leads to the constant Markov rule for the entrepreneurs. But the main results are sustained under a more general environment. The following 3 mild assumptions are sufficient to explain the decline in the entry rate. The first assumption is that the profit of a firm is increasing in one's own productivity and decreasing in the competitor's productivity as a whole. Roughly speaking, more of the better competitors would decrease one's own profit. The partial ordering defined between measures of productivity is similar to first-order stochastic dominance, but generalized to allow for the differences in the total mass of firms. This natural condition is also satisfied under CES and CRS. The second assumption is that ideas or blueprints do not depreciate over time, while new ideas can be found by the workers. This is an assumption that was already made in the previous slide. Then the distribution of all existing ideas, denoted by μt here, monotonically increases over time in the first-order stochastic dominance. Combined with the first assumption, the threshold idea must rise monotonically over time. This can be thought of as an increasing maturity of an economy as a result of accumulating more and more ideas over time, while keeping only the top end of the distribution. Finally, the third assumption is that the distribution of new ideas is fixed over time. Combined with the previous two assumptions, the probability of finding an idea above the rising threshold decreases over time. And this is sufficient to generate a declining entry rate. Now let me explain what I mean by fair comparison between incumbents and entrants. In the model, there's an increasing degree of selection over time, which can be seen from the rising threshold. On the incumbent side, the rising threshold induces the low productivity firms to exit. Similarly, on the entrance side, the same rising threshold should discourage the low quality entrants from entering the market. Throughout the paper, I'm going to define the benchmark as the case where both the incumbent and entrance distributions are fixed, as in the previous slide. Then this benchmark achieves a fair comparison because both incumbents and entrants are subject to the same degree of increase in the selection. In contrast, the existing workhorse models of firm dynamics or creative destruction that feature stationarity in the age distribution of firms cannot do this kind of fair comparison. And why is that? Because in these models, incumbents and entrants are not treated equally for the sake of maintaining stationarity. Here is some more formal discussion about the fair comparison. In the benchmark economy, where both the incumbent and entrance distributions are fixed, the law of motion for the distribution of active ideas looks like this. The first term is the previously existing ideas, and the second term is the distribution of new ideas, H, multiplied by the rate of arrival, eta. After combining these two sets of ideas, it is going to be truncated at the current equilibrium threshold, AT star. Iterating backwards up to period 0, we get the next equation. Note that the rising threshold implies that if an idea is not used in some period, it will never be used again in any future period. So there's no need to keep track of the measure of ideas below the current threshold. Also note that the age distribution of firms cannot be stationary. For example, the share of new firms would decline at a rate of something like 1/t. Now let's turn to the stationary case. In order to keep stationary, some disadvantage has to be imposed on incumbents to make room for the same mass of entrants in each period. For simplicity, we can fix either the entrants or the incumbents. Fixing entrants, the law of motion would look something like this. It doesn't have to be this particular form, but the key is that the measure of previously existing ideas is not sustained and instead becomes stochastically dominated by its own previous distribution before truncation. In Hoppenheim, mean reversion among survivors implicitly does this action. There is an exogenously given Markov process that governs the dynamics of idiosyncratic productivity. At the stationary equilibrium, high productivity firms move down on average, and the low productivity firms move up on average. But because the low productivity firms exit, they don't get to show up in the next period. So this upward movement is missing. That's why the distribution of incumbents decreases over time in terms of stochastic dominance before truncation. Similarly, fixing incumbents, it has to be the case that the entrance distribution improves in each period. Let me now summarize my stance on the benchmark that I just defined. I'm not arguing that the benchmark is what we would expect to see in the data. It is just a point of reference for making a fair comparison between incumbents and entrants. For example, If the age distribution is stationary in the data, this means that entrants are improving faster than incumbents by some constant rate. But we cannot make such interpretation if we use stationary models. Okay. So far, I have explained my model, what I mean by fair comparison, and what I mean by the benchmark. In the next section, I will introduce the entry index, which is an alternative measure of entry. Before getting directly into the entry index, let me first discuss the incumbent firm's advantage, which is a closely related concept. In general, we can think of the incumbent advantage as some notion of gains in productivity or profit as an incumbent firm. The potential sources of the incumbent advantage would include R&D, learning by doing, or preemption of the customer base. To my knowledge, the incumbent advantage is usually discussed in static environments, comparing the old firms versus the new or young firms. However, the incumbent advantage is inherently a dynamic concept. Once an entrant enters successfully, it becomes an incumbent firm thereafter. Therefore, the pool of incumbent firms is constantly changing over time. In addition, instead of partitioning the firms into old versus young, we can make this a continuous function of the firm's age. Then it makes sense to measure the incumbent advantage by the cumulative growth in productivity since entry. On the other hand, there are also reasons that the potential entrants distribution would also improve over time. This may be due to improvement in the general technology that is available to everyone, or if an imitation is possible. Considering all this, we can use the relative growth of the incumbent versus the entrant as the measure of the incumbent's advantage in a dynamic sense. To my knowledge, this dynamic consideration of the incumbent's advantage is new and has not been considered elsewhere. Now let me move on to define the entry index. I will proceed with the assumptions of CES and CRS, and in addition, assume Pareto distribution with the shape parameter theta. One benefit of this assumption is that the mass of firms and workers will be constant endogenously. In the benchmark, the incumbent and entrance distributions were both constant over time. Now I will consider deviations from the benchmark. In particular, I allow the distributions to improve at exogenously given rates, denoted by gamma for the incumbents and zeta for the entrants. The capital gammas and z's denote the cumulative growth since the initial period. Using the law of motion, the following is the full analytic solution for the current distribution of ideas. Since everything is Pareto with the same shape parameter theta, the distribution of each cohort of firms in any period is simply a scalar multiple of another cohort or the initial distribution. The current distribution of ideas can be expressed as the product of the initial distribution, the cumulative growth of the initial cohort, and the sum of these scalars that corresponds to each of the current and previous entry cohorts, normalized by the initial cohort, where this one corresponds to the initial cohort itself. Each of these scalars are defined as the entry index, denoted by E of k, and this depends only on the time of entry k, and not on the time of observation t under the current assumptions. Some more discussion on the entry index. From the data perspective, in period t, the entry index measures the share of cohort k relative to the initial cohort, where the initial period can be chosen arbitrarily. From the model perspective, it is derived from the difference in the cumulative growth between incumbents and entrants. The benchmark corresponds to the case where all the zetas and gammas are 0. So in that case, the entry index becomes a positive constant. And this is the case where there is no incumbent advantage or disadvantage. Now, if there exists an incumbent firm's advantage, that means incumbents are growing faster than the potential entrants, which means gamma is greater than zeta. Then the current entry index would be smaller than the previous period. In other words, we can interpret the declining entry index as evidence of the incumbent advantage in the dynamic sense. The cumulative sum of the entry index, including the 1, is defined as the maturity index and denoted by capital E. This term describes the current maturity of the economy. In the benchmark, the entry index is constant, so the maturity index grows linearly over time. The threshold productivity can be decomposed into the extensive and intensive margins. The extensive margin is simply the maturity index to the power of 1 over theta, where theta is again the Pareto shape parameter. The intensive margin is simply the growth of the incumbent firms. This is a useful object because many of the aggregate variables, including average productivity, aggregate consumption, and real wage, are all proportional to the threshold productivity. Here I compare two special cases. One is the benchmark and the other is the stationary case. In the benchmark, the entry index is constant, the maturity index grows linearly over time, and the entry rate declines at a rate of 1 over t. Under stationarity, the entrants grow faster than the incumbents by a constant rate, denoted by delta here. This means that there is an entrant advantage or the incumbent's disadvantage. The entry index grows exponentially over time, and the maturity index also grows exponentially in the long run, regardless of the initial distribution. And the entry rate converges to a constant. In this section, we have defined the entry index and the maturity index, as well as how they are related to the incumbent firms' advantage. The next step is to infer the entry index from the data based on the share of each cohort. And from this, we can back out the relative growth rate between incumbents and entrants. Now, let me move on to the estimation and the quantitative exercises. Here is how I estimate the entry index. We can directly infer the entry index from the relative share of employment in the firms of entry cohort K in period T, normalized by the share of the initial cohort in the same period. And this is simply given by the data. To better fit the data, I add age effect and non-parametrically regress the relative shares of employment on the entry year K and the age of each cohort, which is simply T minus K. As a normalization, the age effect is set equal to 1 for the age above 20. Now, here's the main estimation result. The top panel is the entry index, and the bottom panel is the age effect. The entry index was first increasing and then decreasing, but if I take a linear fit, the slope is very close to 0. So the US economy has been close to the benchmark, where incumbents and entrants improve at the same rate. So the incumbents' advantage seem to be very small in the aggregate. My interpretation is that the incumbent advantage exists within each industry, but because there is an expanding set of industries over time, it does not necessarily show up in the entry index at the aggregate level. The level of the entry index shows that we have been finding about 3% of new ideas annually relative to the pre-existing ideas in 1976. In this figure, the solid black line is the same entry index. The dashed black line is the growth at the extensive margin as implied by the model. And the dotted red line is the measure of labor productivity growth in the data. Because the entry index was close to constant, the maturity index has been growing linearly over time, and therefore contributed to the productivity slowdown at the extensive margin. But this measure is not directly comparable with the productivity growth yet, because we need to divide by the parameter theta. And now, this is actually the first time that I ever need to calibrate any parameter. There are two parameters, the elasticity of substitution between varieties, epsilon, and the Pareto shape parameter theta. We can calibrate these two parameters using the markup as well as the ratio between the number of firms and workers. Using the baseline value of 5 for the theta, this figure is how the aggregate productivity growth would be decomposed into extensive and intensive margins. By subtracting the extensive margin growth from the total growth, I get the intensive margin, or the growth of the incumbent, which is the solid blue line. Combining again with the entry index, I can back up the growth of the entrant, which is the dashed green line. One caveat of this graph is that the timing is probably not accurate because the entrant growth is entirely attributed to the time of entry. Now let me move on to the effect of population. Why do I consider population growth? Because it is one of the leading explanations for the declining entry rate. And in addition, it is at the core of the semi-endogenous growth models. I assume that the larger population finds proportionally more ideas at each point in time. Then the entry index would be modified as below. In addition to the relative growth between entrants and incumbents, now it is multiplied by the current level of population. To recover the incumbent's advantage, we need to divide the estimated entry index by the current population. I call this population-adjusted entry index. The solid black line is the same entry index. The dashed black line is the population-adjusted entry index, and the dashed red line is the hypothetical entry index with a constant population growth of 2%. First of all, comparing the red dashed line and the solid black line, the declining population growth has contributed to the decline in the entry index, which is consistent with the literature. However, the population-adjusted entry index is declining over time. That means without population growth, the entry index would have declined, which means that incumbents were growing faster than the potential entrants. An important point here is that although the population growth has declined, the level has been still increasing and therefore contributed to a faster improvement of the entrants. And the existence of this incumbent advantage, even in the aggregate, can serve as the evidence against stationarity. Now let me conclude. I propose a framework that allows for a fair comparison between incumbents and entrants and measures the incumbent's advantage in a dynamic sense. I provide a new perspective on the entry rate. Decline of entry rate can be due to improvement in the incumbent firms as opposed to decline in the entrant performance. Even if the incumbent firms are not improving, positive arrival of ideas and the subsequent entry of new firms alone can lead to a stronger pool of incumbent firms over time. And therefore, decline in the entry rate is natural unless there are incumbent firms disadvantaged. And that's it. Thank you very much for your attention.